Good afternoon. Welcome to the EasyPower webinar series, and welcome to our presentation, Garbage In, Garbage Out, Accurate Field Data Collection Strategies. My name is Steve Abbott. I'm the president of Stark Safety Consultants, and I will be the presenter today. Just briefly background, 23 plus years with electrical safety training, arc flash analysis, program development, as well as electrical safety policies and program consulting services. Have spent the last half a dozen years working with the National Joint Electrical Apprenticeship Training Committee, newly found and newly established name Electrical Training Alliance. We've taken part as part of their National Advisory Committee for the NFPA 70E, and I've been a part of the National Electrical Contractors Association's Incident Energy Task Group. What we're going to cover today relates to arc flash study field data collection, and specifically discussing the following topics: dealing with existing documentation, existing one-line diagrams versus field verification, and some of the pros and cons and pitfalls with dealing with those two components of doing the arc flash evaluation. We'll talk about, with respect to the field verification, the data collection team, those individuals that are involved with verifying or collecting the information needed to do an accurate arc flash assessment, both the qualifications from an electrical safety standpoint and some of the details and skills needed for that specific task in the field, both responsibilities and the duties that they would have to get that done. One very important concept to discuss will be the photographs and photos that may or may not need to be taken in the course of that field verification. So we'll talk about the who, the what, when necessary, and trying to give you a bullet point list and some pros and cons, things to consider related to when photos not only can be a valuable asset, but also when they're very critical for documenting the accuracy of the information that's in your study. We'll talk about some issues with difficult to obtain data, hard to reach, hard to get to, and when power may ultimately have to be shut off just simply to gain access to the equipment you need, as well as other hazards that may be involved in the context of getting that information. And then we'll look at some sample data collection problems, some pitfalls, some typical things that we see in the course of doing a lot of our arc flash analysis reviews, where we actually will go through and review other studies that have been done on behalf of the client to ensure that they're getting the most accurate information possible. This course that we're presenting, this webinar, is basically an overall course that we have, our 2-day arc flash data collection boot camp, with the items that you see on the screen. It's an overall hands-on and both technical and work practice methods for collecting that field information at the end of the day to make sure it's the most accurate representation of what is in that system. We'll also look at some back-end steps discussing deliverables, installing labels, and some concerns and some conditions and some information related to the best practice for installing labels and things to look for, and also ongoing tracking changes, which probably one of the most important things to discuss even before you begin this field process, to make sure that you have the ongoing information that you need to keep it up to date. We also have an advanced boot camp class that we'll talk a little bit about, a couple things in here, but this is more elaborate, more complex devices, unique systems, such as a very large system or something that has quite a few scenarios with tiebreakers or loop configurations, as well as dealing with a brand new building versus an existing system that has a lot of maintenance and upkeep issues that may need to come into play. We'll also talk about other things that can be done in the context of collecting the arc flash data, such as getting other necessary information that might be valuable and can be used in context of building lockout tagout procedures. Their information for hazard mitigation and reducing those hazards. So a lot of things that you can do with the goal, keeping in mind when you have to open up a cover to get information, you want to get as much information as you can so you don't have to open it up a second time, reducing the risk and the hazard to the individual who has to get this information, and from a time standpoint, getting as much done at one time. Keeping in mind this class is our suggested approaches for data collection for arc flash studies. This is Stark Safety Consultants' methodology and process. This is not indicative of any specific requirements, even though we'll be using some standard information as the context and basis of our process. We want to make sure the most important thing we do here is understanding the importance of getting it accurate, and anything we do outside of that, be prepared to answer the question after the fact, why or why not, when it comes down to why did you choose to do or why did you choose not to do something in the context of your arc flash evaluation. The purpose of this webinar is to focus on one very important thing, and that is to translate what is in the field into something that can be put into the EasyPower model to generate that accurate representation, and how critical it is to make sure that we get it right. And how do we know it's done right? Unfortunately, it may be too late when you find out, especially when it's dealing with someone who's using this information to protect themselves while they go about doing their work. Entitled for the class, Garbage In, Garbage Out. Data collection is probably one of the most, if not the most important parts of the overall arc flash analysis. No matter what you get in the field, if it's not right, you're not going to be able to turn it into something that will always be appropriate in the model. So garbage in, garbage out. So let's start by talking about existing field documents or existing one-lines versus that field verification. And we need to understand what we start with may or may not have every bit of information that we need. Looking here, we have a typical electrical one-line diagram. There's a lot of information on there, but unfortunately we don't always have all the details that we need. Breaker settings, wire lengths, wire sizes, fuse information. We don't always have that. We don't always get all that detail. Compared to an arc flash analysis diagram generated from EasyPower, here we have a lot more detail, a lot more information, a lot more depth that we need to have, and such as fuse information, size, wire length, conduit, all those information. There's a big difference, so we need to make sure we have that information. And if it's not on the diagram, we may have to go physically get that in the field. Now, one myth or one problem that we see quite often is when we do go out and we map field information, we are trying to get what's there. So we shouldn't be drawing what we think should be there, or we shouldn't be drawing how we think it should be or how we would want it to be. We need to make sure that when we're mapping the system, we're collecting that field information, we're representing what is actually there, the good, the bad, and the ugly. So we need to make sure we don't try to sugarcoat anything when we're documenting field conditions. Field conditions, why it's important to get the field conditions is you may have a good document, but those field conditions may have changed since that drawing was done, and it may not be consistent with any as-built. So from brand new construction, you get an engineered construction diagram or drawing, then you actually build that and put that equipment in, and someone should be documenting as-built. So we have a lot of steps, and we do have some variation that could come into play without verifying the field conditions. Just looking at a couple segments from IEEE 1584A, you can take a look and see that just clearly in this document they're echoing the sentiment that the largest part of that study is collecting the field data. There's a lot of required information we have to have, and we have to have current information. Even if we have an up-to-date one-line diagram in place for time current curve and short circuit study that may be in the computer, the field part of the study could take as much as half the amount of time to do the overall study. Very important that we understand that we have to go get the field conditions. And lastly, even if it's a brand new drawing, there still could be a situation that we're going to need to verify what's changed from the construction drawings to the as-builts. So we need to make sure we don't underestimate that. And same time, one of the most important things also is making assumptions. By not going out and getting that information, you know what they say about assumptions. So it's very important that we get that information and we don't take for granted, or we don't make any overemphasized assumptions. Here's just one time curve showing you where we've looked at a generic device, and the system in EasyPower can give you some generic devices, so we have to be aware of the pros and cons of that. The generic setting versus the actual setting. So we've just taken one out of one of our systems that we've analyzed, and now granted, this one actually shows a difference in 12 seconds of clearing time from the generic setting to the actual real device. And in this case, it actually could be a huge advantage, because we go from something that is extreme danger above 40 calories to something that is actually below 1.2 calories, which could ultimately be where we could justify no arc-rated clothing. So there is a huge gap in some cases, and so we want to make sure we get it right. Probably the best statement that I've heard is, the more assumptions that you make, even how minute they could be, the farther and farther your model gets from actual reality of what's out there in the field. So we want to be really very conscious about making those assumptions. As well as from the arc flash calculations, field verification and making assumptions that just because the information might be right. Here's a picture that shows the importance of field verification from just conditions of equipment. So here the blades have all been open, but the B and the C phases are still energized, showing here 338 volts both on those phases because water has rusted in there. So field verification has many different values, and here's one just being able to see where you may have some conditions that could affect your not only calculations but the actual performance of the equipment. Got two other pictures here that can also be something that field verification would be the only way to point out. On the left, clearly evidence of layers and layers of information over time that could have been changed in the facility, and depending on how old your drawings are, could really be varying from what your model may be in field conditions. To the right, we see evidence where someone had stuck some copper tubing right up against this disconnect switch. Had we not field verified, we would have not known this issue existed, which obviously it looks like there might be even a case where the switch couldn't even be turned off, let alone open for servicing. So field verification has a lot of different values. Part of our data collection camp series, we do have a top 10 electrical safety program and an arc flash study document, do's and don'ts and pitfalls. Here we're going to just give you our top 5 just for the length of time that we have, and this is our top 5 assumptions. So these assumptions are a part of a lot of our third-party reviews, reviewing other arc flash analysis and studies that customers have had other experts or companies do, and they've asked us to review those to look for gaps or concerns. And these are 5 that are assumptions that were made, found in the actual documents, whether it was a proposal or also the finished deliverables, the drawings or the arc flash study reports. And all of these have context related to the field verification. So we'll look at the first one, and the first one is referring to number 5. For the low voltage circuit breakers where the adjustable settings were undeterminable, the high setting was used. So taking a lot for granted there, not to mention not able to do coordination accurately. Number 4, assumptions were needed because of limited access or lack of documentation. So I'll back up a step. All of these, again, prepare yourself. If you have a study that you're using these phrases in the context of these phrases, be prepared in the event of an accident, you're able to answer why. Why were these assumptions made? Why did you use these? So if you can't get access to it or lack of documentation, be careful about using the same kind of assumption you would for justifying why you're going to do the work energized. It should not be because of convenience or because of money. Number 3, some assumptions for input data were required and may affect the results of the study. If you're paying somebody to do this and they're telling you that what they're giving you may not be appropriate, again, why are you choosing to do that? And be careful about money being as the significant response. Number two, significant differences between assumptions and actual values will require that this power system analysis to be revised. And it goes right along with number three. But again, these are things that we see more often than not, and more times than we would like to see in finished study deliverables. And last but not least, number one, and I've kind of mentioned it a couple times here, but it was actually listed in a report in an effort to save the customer money. Hopefully that should never show up in anybody's report, but unfortunately it has. So just keep in mind the concerns with making assumptions and the decisions that you're making for those assumptions in the context of doing your evaluation. Now let's shift gears and talk about the team. And we talk about the team because there are some value and some issues with doing this individually or as a part of a team. Most importantly, who should be gathering the data, keeping in mind that you're going to have to open up boxes, you're going to have to get information out of cabinets. Hopefully you're staying beyond the restricted approach boundary, so it's visual inspection. So you could potentially be doing that with the power on, and definitely it's the chicken and the egg. You need to have some protection on while you're getting information to do an appropriate assessment. So you may be in a situation where you may need to use the simplified method listed in Annex H in the back of the NFPA 70E because there is some danger in doing this. So who's qualified to do this? Very important that we give that some consideration, and very important that those people not only have safety qualifications but also qualifications related to the process of getting that information and the experience of getting it in a variety of different types of cabinets and conditions. We do have part of our data collection boot camp what we call our qualified field affiliate program, where we will actually train and qualify individuals in the context of collecting data, so you have some validation of the skills and knowledge of the individuals who would be doing that. But that's, again, you want to take a look at who's getting that information and why. So we look at a team. When you think about what you have to do to get that information, we have two clearly important people in this process. So the first person is the collector, and that's the person that actually is going into the cabinet, getting the information, and is going to have a lot of technical skill and knowledge working around cabinetry, getting in and out of cabinetry, going to have to be very aware of different types of equipment that they're getting into, going to have to be the one wearing personal protective equipment, be using insulated tools to open up doors and cabinetry. They're basically there to get the information. Now, why we use the second person, which on the far right, the recorder, who documents the information that the collector is getting. Just think about a couple of logistical issues here, just looking at the picture. Person has a shield on, person's wearing gloves, person has to open the cabinet and close the cabinet. Not very easy, not very time conducive to be writing this information down or typing it in a computer without having to open, close, take gloves off, take the hood off, and do a lot of different things. So we have used this approach because it actually, in the big picture, makes us much more efficient getting through the system, much more risk reductive because we have someone there for rescue. We also have somebody there kind of looking at the big picture. The recorder is getting that information, jotting down all the information, making sure they see the big picture, and as we're going to get into here in a few minutes, photographs. Telling that collector when we may need to get a photograph. That person, not a lot easier to take a picture wearing all this than it is to write a lot of information down or type. So they're very interdependent on each other for a lot of different reasons. And again, we want to try to get everything we can without shutting that or having to open that door twice. So this can be a very, very helpful piece. Also, dealing with safety issues. That recorder is very helpful when the person collecting the information, their face is in front of that cabinet. The recorder is kind of back away. They see the big picture. They see other hazards. They see other traffic, things going around. So it also can be very useful to that person to protect the individual collecting the information, as well as making other people aware that are surrounding that may not necessarily see clearly the arc flash boundary until they get a little bit closer. So there's a lot of different roles that they will play. So let's talk about photographs. Let's talk about the who, the what, and the when. So let's look at those type of things. We have our own default list, and the reason for those is for a couple reasons. So number one, it's probably for the last 7-8 years we've been very, very critical on getting photographs. Photographs play a huge part in not only getting information that's hard to write down, but also document details that after that cabinet's closed, you don't have as good of a record of. So adjustable settings would be a very big one. So that when we do that study, if somebody were to make an argument that our calculations were not accurate, we have a photo of the settings. And when you talk about photos, you always want to make sure you have that date stamp on the digital photo to document the date that you took the picture. For that other reason, that the data that we collected at the date that's on the photograph is what the study was based on. If 3 months or 3 years later someone questions the calculations, it could be that unfortunately we found that someone came in to do some maintenance and forgot to adjust the settings back when they maybe adjusted it temporarily for the work that they were doing. So there's a lot of liability protection that taking photographs has. But when you start looking at some of these items on here, anything with more than one protective device inside, a control cabinet, which can have all kinds of designs and setups, very important to take that. So if the engineer that may or may not be there can take that and go back and look at it when they are doing some part of the final review analysis of the model. Again, breakers with adjustable settings, motor control centers. Sometimes the backed up picture just to see how the cabinets are connected in the different sections to help determine where labels need to go. Same thing with switchgear and substations, multi-sectional pieces. Very helpful in that final review analysis portion when you see how things are connected. Maybe it could be several days or weeks after that field data has been collected, and you just need to have something to remember. Wireways and troughs. You open that trough up, you want to take a picture. It may help you to see wires going in and out of all the different conduits to better map things out or double check what you're writing down. Obviously, anything that you can't get the information you need, physical damage, worn out or painted out nameplates, safety issues that you've encountered or damage or concerns on that equipment, having that picture not only can help for doing research, it can also help to document the before so that when you go fix something, you can document the after for documentation and evidence that corrections have been made. And then finally, anything that you're not able to access during the data collection, there may be a legitimate reason you can't get into it without turning the power off. Doesn't necessarily make the best argument that you're going to make an assumption. You just may have to go back and schedule at a later date to go in there and get that information. So a picture sometimes helps. You can put that picture and you can document and put that in place to know specifically what device you may still not have. Again, showing you pictures of breaker settings, why it could be so critical. Here are just 3 different pictures of 3 different types of breakers with 3 different types of setting dials. And to ensure that the person writing it down or typing it in doesn't make an error in their translation, the pictures again can play a huge part for that engineer or that analyst that's doing the actual model or doing the final review, as well as the importance of using this information to validate any time current curves or mitigation strategies that might be in play. Now, one thing I didn't mention is picture logs, and I'll show you here's another picture where you may not be able to see the dials very good, but it's important to have that picture. And picture logs are just as important as pictures. If you're taking hundreds or even thousands of pictures in some size facilities, you want to make sure that they're tracked properly and make sure you understand how your camera works and your picture log so that every day it doesn't start at picture number 1 and you find out after a week that you have 5 picture number 1s for 5 different pieces of equipment. So you want to make sure you're very clear on how your pictures are being tracked and logged. not only taking pictures, but making sure you take good pictures and you verify you have a good picture before you move on. Here are just 4 examples of some photo concerns, or when you need to have pictures, but it's just we showed on our bullet point list. Again, painted over nameplates. You might want to get a zoom back picture to see the whole cabinet to make sure if there's something you're going to have to do some research or send to EasyPower Tech Support to help find representation of that piece of equipment. To the far upper right, painted over, but also completely scratched off or worn off. It's not readable at all. To the bottom pictures, which have to deal with bad photos. So the bottom left one's not out of focus unintentionally. That's actually how the photo was taken in the field, and clearly it's not usable. So not only do we not want to have to open up a cabinet twice, we sure don't want to have to make a trip back out to a facility if that's the case. So a bad picture, can't read it. Bottom right corner, same thing, a bad picture. The flash flooded out and washed out the data plate. So we want to make sure we have a good photo before we leave and move on. Could create a lot of headaches later. Talking about difficult to obtain data. So a couple different concepts of difficult data. Number one, just the sheer magnitude and size of a facility. So overwhelming scope can be a huge issue when it deals with obtaining data. And this one kind of comes into play because we have so many machines, so many processes, so many things going on. Ideally, a lot of people would love to be able to start at the top, work their way down, and go continuously. But unfortunately, it never works out that way. There's always going to be something in the middle, something in the way, something that you have to bounce around because of work going on or access or just a lot of different things. We'll talk about a couple here. So you want to have a game plan in place, and you're going to have a way of documenting where you've been and where you still have to go. So basically a method of leaving breadcrumbs, so to speak, to know where you've left off. When you start looking at a large system, you can be very easily to lose your place, very easy to lose where you've been, and really easy to forget items and where you have to go back to get. So you're going to have several different logs to keep track of those things. This is just one system that had 17 substations, and here, looking at the list as it scrolls up here slowly, 34,000 plus points that had to be modeled, that had to have data collected. So we're looking at quite a few points and a lot of system that had to be traced and tracked out. This was a study that was partially done and was needed to be finished, but also field verified of the existing model that was in place. So you can see quite a large number of devices and components. Another issue with data is just safety. Hazardous conditions. We have some conveyors here, so we have movable parts. We have open flames underneath where we may have to get. See the couple arrows? We have transformers and troughs and bus plugs. So being able to field verify those, you're not going to be able to do those at the time that you necessarily want to do that. There's going to be some coordination, collaboration, and dealing with looking at the right time to be able to safely get those things. The next picture showing again similar kind of issue with hazards. So here we have a situation where in the background you can see a conveyor that's moving this assembly line of equipment, and a huge portion of this system was bus plugs and bus duct, and it was all above the conveyors. So this had to be done at scheduled times when the bus plugs could be accessed, meaning the conveyors were able to be stopped. And it was only a couple times throughout the week that was able to be done. Of course, it wasn't normal business hours. And another hazard, you can see we had this walkable mesh grating that is about 30 plus feet above the ground. So we have a lot of safety issues that may or may not need to be looked at in the context of collecting that field data. So a couple things here we'll look at next with some pitfalls, some pros and cons with looking at collecting data. And one of those is just how well you map the system out, and wireways and troughs are a big one. And you can't take for granted that that's just a box and you're going to only map out the protective components such as breakers and fuses. We need to be able to accurately map this out. I'll show you a diagram that could, that is an example of this particular trough. The original data was mapped and marked as it shows on the left, which is incorrect. And you can see on the right that some of the connections, the feeds and loads, were actually split off here in reality. That could play a big part in available fault current and the actual arc flash calculations and resulting. So it's important that we map that system out correctly. Not to mention, it could play a role in just connectivity and lockout tagout. We may not necessarily have a good drawing for that as well. System connectivity, you're opening up boxes. Another pro and con or pitfall, so to speak, to be aware of is just the danger. How often you open up boxes and you see unprotected connections, as you see in this picture here. Very common. You have another trough example of a similar application on this next picture, and you can even see where they put some electrical tape on the ends just because it was rubbing up against that cabinet and they didn't want to have that live conductive part. So you never know what you're going to get into. You never know who was there last, what they did, what their knowledge or skill or qualifications were. So you always have to go in there prepared for the worst or prepared for unknowns when you open things up. So we definitely don't want to get too comfortable when we do that. Some big setups of gear and assembly and components. Here's one where we want to make sure we don't forget to check the overall connectivity. All these different buckets, the wires came in and out of this top busway connection up at the top, so we need to make sure that we're mapping that out and we don't take for granted just opening up each cabinet. We need to open up this top and we need to look and see how all those wires are connected. Difficult to obtain information could be covered data plates. Now, you may not be able to get it. Now, there's some tricks that we won't really go into in this, but we do have some tricks of how to get the information without having to take this nameplate off. But for the most part, there's situations where you may not be able to get it. All the catalog number information is behind this plate, and you may have to remove the plate in order to get the information. Very common one is with fuses and just simply mismatched fuses. So there should also be highly recommended a plan in place before you start your field verification. What is the process of how to address mismatched fuses? Ideally, collaboration of consolidating those fuse types and making them all the same. Ideally would be while you're in there, but you may have to shut some equipment off to do that, so it may not be conducive to your scheduling and the work that's going on. So having something in place, having documentation to know which devices need to be done, and if you can get those fuses consolidated in the context of finishing your model, that would be the most advantageous. Without that, then very difficult to know which phase the arc could potentially start on, and very seldom are you going to run multiple scenarios for each device times how many devices, so it becomes very impractical to do so. The only alternative that we've come to deal with is just modeling this as a non-fuse disconnect and noting that it's because of mismatched fuses. Now, it shows you no protection, which may in some way could be considered a conservative way to provide protective results. On the other side, it also means you're not able to do a very accurate coordination evaluation. So there's another assumption that could be detrimental to the accuracy of your evaluation. So identifying how you're going to tackle these mismatched fuse problems is definitely something that at the front end would be the most advantageous. And then at the end of the day, you may just get in a situation where you find equipment that's in such bad condition that it's not responsible to do any evaluation on this other than showing that there's no protection there, and ultimately trying to figure out a way to get this corrected before you finish your model. Putting a label on a piece of equipment like this is, kind of ludicrous to some degree. So sooner or later you may just have to say, no way, we're not going to include this in our analysis other than to say that it needs corrected. At the end of the day, we're wrapping up this presentation. This is just a short presentation to give you some of the highlights of the different aspects and concerns and things to consider for field verification and doing your arc flash study data collection. As a part of our overall data collection boot camp course. Remember why you're doing the arc flash study to begin with. Hopefully most of your safety programs are not based around being compliant. Compliant is doing the absolute minimum. Our goal should be to keep people safe, give people accurate information that allows them to appropriately pick protection that they would need and work practices to keep them safe. And hopefully our motivation is driven on being able to have our worker go home at night safely, day in and day out. And if we use that as our focus, that hopefully will help us make those decisions about why or why not more appropriate. How do we do that? Again, get trained. Make sure you know what's involved and the proper way and the proper information needed for the information that we need to have for our arc flash studies and our models. We'll leave it now. Just if you would like information about our data collection bootcamp classes, information about our third-party reviews to review arc flash studies that have been done, especially if it was done for your facility and you do not have necessarily the detailed experience in-house and would like someone to help you, please contact us at the number or email below. Be happy to assist you or send you information on our upcoming classes. We have quite a few classes, January and February, coming up in 2015 around the country. We'll be doing regional arc flash data collection bootcamp classes. So with that, we thank you for attending the webinar, and please look for the recording of this on the EAS website, which should be up very soon, and continue to support EasyPower with a lot of their different products and services. Thank you for attending.